Okay, so we have moved on to part 2 of homework 1 for quantitative. This is going to be the Excel part, and I promise you it's pretty easy. So the first thing that we're going to do is download to Excel from Yahoo Finance the last 5 years historically daily data on Apple and Amazon. So let's do that. Let's look up Apple. Make sure when you're setting your data, by the way, go to historical data and select 5 years. So you can see it adjusted to 2014 and make sure it's daily and always click apply. Okay, so now that it's applied, we can download data. And let's do Amazon as well. So even though it says 2014 and 2019 and daily, you still have to click apply to make the changes apply and download data. Okay, so we've downloaded our data. I'm just going to go ahead and put them into Excel right now before we move on. Again, I'm working with a Mac, so if you're on a PC it might be a little different, but I believe in you that you can figure it out. So all I'm doing is I'm opening both CSVs in Excel, and then I'm just going to combine them. So I'm just going to move our copy, move to the other one. Okay. So now I've combined them both in one sheet just to save, just to make ourselves a little bit more efficient. Okay, so we can get rid of Yahoo Finance. Thank you. You have served us very well. Great. So we have done part 1. We downloaded the last 5 years of data. So calculate the simple daily return for both stocks. That's part A. So first, you need to remember what you need for a simple daily return. We can get rid of most of the information. So we don't need the open, high, low, or close. So I'll just command minus that, or volume, get rid of that. And the same thing for Amazon. We don't need open, high, low, or close. So you can get rid of those. And volume, get rid of those. So let's do everything on a third tab. The date should be the same for both. So we can just copy in one of the dates. We'll take the adjusted close for Apple, and we will name it adjusted close. Here, yeah, we should do values only, by the way, when you paste things, just so that stuff doesn't get messed up. Adjusted close Apple. And let's bring in the adjusted close for Amazon. Adjusted close Amazon. I know I'm going a little fast, but this should all be pretty rudimentary stuff, so I'll slow down when it gets to the actual complicated things. Okay, so, and you know, just for those with OCD, we'll freeze the top row and everything. Okay, great. So now we have the date, the adjusted close for each stock. So one thing that we're going to do real quick before we start is we're also just going to, where is it? We're going to sort from newest to oldest. That'll just make it a little easier to work more intuitively. So this is the most recent stock price going all the way down to the distant past. Okay, so what do we have to do? We have to calculate the simple daily return for both stocks. So what that essentially means is you're calculating the percent that the stock changed from the day before. So let's do daily return of Apple, and let's do daily return of Amazon. Let's size all these up so we can see everything. Okay. So since we're taking the price of the day before and dividing it into the next price, there will be nothing in the first day. Because, as you'll see in a moment, it's physically impossible to know what's happening in the future. So we start from the day before. We take the most recent price. Here, I'll put in parentheses. We take the most recent price. We divide it by the day before, and we subtract 1. So you should get a number that's less than 1, that's between absolute value is less. Well, actually, that's not necessarily true. You can get something that's greater than 1 if there was a massive change, but basically you can see that you wouldn't be able to apply this formula here because then you would be dividing something that wasn't a number by something that is a number. So you have to start from the second day. So that's the daily return for Apple. It was negative on that day. Amazon's was also. And we can double click to apply it to all of the returns. You should always just scroll down real quick just to make sure that everything is ending on the same date, which it is. Okay, that was all technical stuff. That's very simple. So again, calculating the daily return is just taking the day before, or like the most recent day, dividing by the day before, and then subtracting 1. Okay, super easy. So we've calculated the daily returns for both. Next, I'm just going to move this. Do you think Apple or Amazon... Oh, sorry, we're on part B, my bad. Okay, part B. Using the data analysis toolpack, calculate descriptive statistics on the daily return. Okay, this is super easy. In the previous part, we had to do all this by hand, but now all we're going to do is have Excel do all the hard work. Leave columns F and G open because we're going to need those soon. So we're simply going to go to data analysis, descriptive statistics, okay, and we're doing descriptive statistics of the daily return. You could do it of the price too, but there's no need to do that. So we are going to mark labels in first row. The input range was already selected for me because I did it earlier. And all we need to mark is summary statistics. That'll give us everything we need. And our output range, we'll put it there. That's fine. Okay, so that's all you have to do. Select your data. In this case, it's the daily return. Select where you want it to go. And labels in first row, summary statistics. That's it. Okay. So you can see we got our daily return of Apple, our daily return of Amazon. Here, I'll put a little line between these, just so that you can see a little bit more clearly which is which. And you can see it gave us our mean, standard error, median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum count. It gave us everything just with a touch of a button. How fantastic. Don't you just love Excel? Okay, so that was pretty easy. Now we have to use that data. So do you think Apple or Amazon daily stock return are normally distributed? Explain. Remember that there are a few factors that go into normal distribution. I'll let you look at the notes and recall exactly what those are. But some of the easiest ones to look at from these results are the kurtosis and the skewness. So here, I'll highlight them for both. Oops. So the kurtosis and skewness, let's start with Apple. Generally, when a kurtosis is greater than 3, it's considered to be a non-normal distribution. So we can see Apple's kurtosis is greater than 3. And a kurtosis of greater than 3 means that the distribution has fat tails, or that more outliers or more extreme values fall in the outlier region, where you would normally expect most things to fall in the average region. With fat tails, you have more probability of outlier results. So we have a kurtosis above 3, and we also have a negative skewness. When skewness isn't 0, it automatically means you're skewing away from the normal distribution graph. So Apple, definitely not normally distributed. Obviously, you would have to do a statistical test to know that for sure, but we can see that it's pretty much not. The same thing for Amazon. The kurtosis is really high, so there's a lot of outlier values. And the skewness is also above 0. It's not 0, so it's skewed away from the normal distribution graph. So that takes care of part C. Now for part D, to tag on to that, do you think the stocks had more negative or positive returns? Explain. So let's start with Apple again. We know that the kurtosis means that there's more outlier values falling on the positive and negative side of things. And with our negative skewness, we can see that those outliers are probably falling more to the negative side of things. So again, we can't know for sure, but we can make an educated guess that Apple probably has more negative returns than it does have positive returns based on the skewness. And the same thing for Amazon. It has a very high kurtosis, so there's a good chance of an outlier falling somewhere in the extreme range. And the skewness is pretty positive, so we can see that Amazon probably on average has more positive returns than it does negative returns. So now part E. Calculate the standard deviation of a portfolio comprised from both stocks with 25% invested in Apple and 75% invested in Amazon. So for this one, you're going to have to remember a little bit of investment theory, because we're going to use this formula, the variance of a portfolio, this lovely one right here. And we're just going to have to set it up real quick before we can use it. So we said we're going to weight the portfolio, right? So we're going to have Apple and Amazon. And we're also going to have to find, what else do we have in the formula? We have the covariance. So let's get our covariance ready. And what do they want us to find? They want us to find the standard deviation of the portfolio. So let's say portfolio std dev. Okay, so let's just get ourselves set up here and then we can do this. So first of all, the weights. We said Apple is going to be 25% and Amazon's going to be 75%. So 0.25 for Apple, 0.75 for Amazon. Our covariance now, this is extremely easy to do. All we need to do is just simply enter covariance.s. Remember that .s is sample. We don't have the population covariances, like the population data, so we're just using sample. So the first array is simply going to be the daily return of Apple, and the second array is simply going to be the daily return of Amazon, and boom, we have our covariance. Once we do that, the last thing we need to do is our portfolio standard deviation, and that is very simply going to be plugging and chugging from this formula. So our variance is going to be the first weight, right? So 0.25 times the first variance, which we can find here. Apple's variance is here, right? Plus the second weight, 0.75, times Amazon's variance, which is here. Okay, so we've covered all of this so far. And then we're going to do plus 2 times the weight 1 times weight 2 times the covariance, which we just solved for. So that's plus 2 times the first weight times the second weight times your covariance, and you get your variance, right? So this is actually variance. This is our variance. So to get our standard deviation, all we're going to have to do is square root, oops, my bad, is we're going to have to square root this, and we get our portfolio standard deviation. So that's how you would solve that. You literally plug and chug for this formula, and it gives you the answers. So that was part E, very simple. And now part F. Calculate Spearman and Pearson correlations and plot a scatter plot of the two prices. So I want to remind you that Pearson correlation is the linear correlation and Spearman is if it's nonlinear. So for Pearson, very simply, all we need to do is use the correlation formula. So let us start with Pearson. Pearson. So this, you very simply, what are we doing it for? We're doing it for the prices. So for the Pearson correlation, all we're going to do is do the correlation between the prices of Apple and the prices of Amazon. And I just need to adjust that so that Amazon doesn't make it in there. Okay, so you can see that it has a pretty high correlation, which makes sense because they're both, you know, almost $1 trillion tech companies, and their sales probably heavily rely on one another. Even if the actual prices are different, the linear correlation between them is very strong, and you'll see that when we make a scatter plot. Now let's do the Spearman correlation, which would account for any nonlinear correlation between them. And for this one, because it's nonlinear, we can't simply use the correlation formula. What we're going to have to do is we're going to have to make a ranking of the, in this case we can use, we were going based off prices, but I think we can I'll do it just with the returns just as an example. But we're basically going to have to rank them, and what the ranking will do is it will allow Excel to see whether there's some sort of other relationship besides linear. Don't need to really get into it, but okay, so let's rank Apple, and let's rank Amazon. Help if I could spell. Okay, so this formula is really easy. Just do equals, and the reason I'm skipping a line, by the way, is because I'm using the daily returns. There is nothing in the first row. If you wanted to rank the adjusted close, you could. You would just start from the top row, but we'll do it based on the returns because on the daily returns, because that's what he does in the homework. So let us do the rank formula. It's rank.average. Don't ask me why. That's just what it is. You're using the first one and not locking it in because you want that to move down each time you perform the function. And then the reference is going to be including the first one, the entire table, and you're going to lock that in. Enter. Okay, so as you can see, your rank, this literally ranks it like this is the 1,114th place in absolute value of rank. We're going to do the same thing for Amazon, so we can just drag this over. Oh no, it won't let me do that. Okay, so let's do again rank.average for Amazon. Going to have that, and then go down and lock in the array and double click. Okay, so that's how we rank. Again, just a reminder, when you rank it, when you use your rank function, you don't want to lock in the first one because you want it to move with each time that you go down, and you want to lock in the array so that that doesn't move. Okay, so now that we've ranked it, we'll find the correlation again, just as we did with the Pearson correlation. You simply take the first array, and then you take the second array, just like that. Enter. So you can see that our Pearson correlation is really high, but our Spearman correlation is a lot lower. So what that means is that there might be some different sort of relationship going on. He elaborates on this a bit more in his own solution, but I don't think it's really that big of a deal. So if you want to, you can check that out. And the last thing that we need to do is plot a scatter plot of the two stock prices. So I think what he does, because he did Pearson based on price, he did Spearman based on percentage. I'm not sure if we could actually compare these two without doing them both on the same thing, but you know, as long as you know how to do them, I don't think it really makes a difference. So we're going to do a scatter plot with Pearson based on the price, and we're going to do another scatter plot for the Spearman based on the return. So first, let's do the scatter plot based on the prices. So you just select all your data. You don't need to select the titles. Insert scatter plot. Literally that easy. It inserted it all the way down here, so I'm just going to Control X and pop it up over here. Okay, so what this is telling us is basically we could see, let's add a trend line so we can get a bit better of a view. We can see that we have a pretty strong R squared. It's a pretty positive correlation with the prices. If you wanted to, you could format your axis, go to number and change this to currency so you could see exactly what kind of units you're dealing with. Do the same thing on the bottom. You can play around with it, but this basically is telling you strong positive correlation between the prices. Cool. So now let's do another scatter plot for the Spearman correlation. That one we're working with the daily returns. So let us select all that data. Again, insert scatter plot. And you can see this scatter plot looks different because now we're working with percentiles instead of with prices. So the axes are labeled on a 4-quadrant axis instead of just on X and Y. So again, let me just take this chart and pop it on up over here. And if you want to make it a little more clear what we're looking at, you can, again, format axis, and under number, you can change it to percentage. Same thing for this axis. You could change it to percentage. You know, you could play around with it. You can add a trend line, which I'm sure on the test there will be some sort of trend line that we'll be able to see, like a best fit line. So what we can see from this is, again, there's a positive correlation between the percent returns each stock has every day, but it's a lot weaker than the Pearson correlation was with the prices. So this is just two different ways of looking at stocks. That's everything you need to know for this homework. I hope that that helps.